Hello everyone, this is Reza Baezi and I'm going to cover concepts related to data preparation in this recording. Hope you enjoy it. Okay, let's review the CRISP-DM or cross-industry standard for data mining. As you remember, it starts with business understanding in a way that you have to understand what the business goal is of and what do you want to achieve with this data mining task. Then I'll go to data understanding, where you have to acquire an understanding of your data, where it comes from, what resources you have available, what are the meaning of each column or each field or variable. And then I'll go to the data preparation, where you have to prepare data for your data mining task, depending on the task, if it is going to be predictive or descriptive. You may approach data preparation differently. We'll talk more about this data preparation through this recording. Then it goes to modeling, evaluation, and deployment. I already talked about this in the previous recordings. It involves use of software to put the collected data or received data into a desired format, the format that is necessary for your mining task. And it typically involves taking care of inconsistencies, taking care of missing values, considering outliers if you want to take them out, if you want to let them be there. Also, you should consider that not all software are created equal. It means that different software have different capabilities when it comes to data preparation. Working with some software are a lot easier when it comes to data preparation than others. Most of the statistical packages and software that you see out there in the market, they provide some sort of data preparation, but some of them provide more and better capabilities. It means that you can do the same task of data preparation using a different software in less time, using less effort. RapidMiner is designed for predictive analytics. It provides some sorts of data preparation, but in my opinion, it cannot match those of even Excel or R or even Tableau. So in many cases, if you are using a software that is specifically made for predictive modeling, made for some sort of descriptive analysis, not made for data manipulation, you'd be better off to prepare your data using a different software, different application package, and then import the data into that application if it is possible. If it is not possible and you are bound to use that software, you can always learn innovative ways to prepare your data and get it ready for your mining task. During data preparation, you'll have to do some data scrubbing that deals with anomalies and inconsistencies. In spite of your very best effort to maintain quality and integrity during data collection, it is usually inevitable that some anomalies will be introduced to your data at some point. The process of data scrubbing allows you to handle these anomalies in ways that make sense for you and your data mining task. You have to find ways to deal with missing data. And what is missing data? Missing data are null values. For example, 0 is not a missing data. When you see that in a cell in your data sheet you have 0, you have a value there. When we call it missing value, that there is nothing, the cell is null. Another way for data scrubbing is to reduce data. And how you can reduce data? You can remove all null observations before mining. That's one way of reducing data. Or you can reduce the sample size for faster processing. Typically, you are dealing with a lot of data, especially that if the data is coming from industry, you are dealing with a lot of data. In most statistical analysis, you don't need all that data. You only need a representative sample of that data. And you may just go with that representative sample to give you a good understanding of the whole population. So you need to also deal with inconsistent data. What is inconsistent data? When you have values that are different from what they are expected to be, these are inconsistent. The out of range values. At the data understanding phase, you need to know about the variable descriptions and variable ranges, so you can verify whether all values within one variable, they are all within their standard or expected range. If they are not, then you have data inconsistencies, or you may have invalid or meaningless data. If data is coming from users, coming from people filling out forms, they may just decide to enter something that is not valid. For example, in all elections, there are some people who write names that are invalid, such as Donkey, such as, I don't know, Luke Skywalker as their candidate. So these are invalid or meaningless. So you can always find some of these, or some data might be invalid or meaningless because of the sensor error. If your data is coming from different sensors within a system, the sensor error may lead to invalid or meaningless data. You have to be able to find these data and deal with them. Another inconsistent data are outliers. Well, outliers, again, depending on what type of task you have in hand, they might be like a poison or they might be like gold. So if you're dealing with some sort of descriptive analysis that deals with average or mean, then outliers can move your average and they can be bad for your analysis. At the same time, when you are looking at outliers, in many cases they may tell you something interesting about your business. These outliers might be something that you are really looking for, that you want to investigate more. So dealing with outliers depends on what you want to do and what is the goal of data mining task that you have in hand. Another strategy in data scrubbing is reducing attributes. You typically are dealing with a lot of variables or a lot of attributes. Some of these attributes typically do not have any effect on your target variable or the variable that you want to predict, especially in the predictive analysis. You can safely take them out and reduce the number of variables. Let only those who are relevant to your analysis stay in the analysis. Even in the descriptive analysis, some variables may not be really meaningful in the data, in the descriptive data that you want to generate, in the graphs that you want to generate. Or another way in reducing attributes is to omit or eliminate attributes with a lot of missing values, with a lot of null values. Now let's focus more on the problem of missing data. So missing data can happen due to different reasons. It might be unknown, simply you don't know what the value is for the specific record. Or it might be inappropriate, such as the date of last childbirth for a male, and it might be expected. To make this clear, imagine that you are having a survey and you're asking if people are using Facebook, if people are using Twitter, if people are using Instagram, and the last question is, do you use any other network? Do you use any other social network? So some people that use other social networks other than those that you've listed, they will put something down. Those who do not use other social networks, they just leave it blank. And you kind of expect to see some sort of missing data in that attribute. So it might be unknown, inappropriate, or expected. You need to know the nature of your missing data, which one of these are, because the strategy you choose to deal with will be different. So now, what are the strategies in dealing with missing data? You can leave them like that. You can leave them null as the first and as the easiest strategy. But in most cases, this will not work for you. You have to do something with them because many predictive algorithms do not like missing values. They do not work if you have missing values in your data. Usually, missing values are not of a big deal in descriptive analysis. You just report that you have this much missing value or this many missing values, but they are going to be a problem in predictive analytics, and sometimes in descriptive analytics that require some sort of algorithm working through that data, such as clustering. Some clustering techniques might be sensitive to missing values. Another strategy is to replace them with an appropriate value. This is one of the good strategies, but what is appropriate value? Is it average or mean? Is it median? Is it mode? Again, it depends on the nature of your data. It depends on where your data is coming. So you need to develop a good understanding of your data in order to decide what would be the appropriate value. In most cases, if you are dealing with an algorithm that uses average or mean of your variable, your attribute a lot in this algorithm, it's usually safe to replace with average, but not always. So you have to know the algorithm you are going to use. You have to know the nature of your data. You have to have a good understanding of your data and a good understanding of your data mining goal. Then you can replace what would be the appropriate value. Would it be average, median, or mode, or even zero, or some other value? Sometimes you would be able to calculate the missing value using other variables in your dataset, or sometimes you might be able to guess the appropriate value using the appropriate missing value using different algorithms that exist out there for estimating the missing value off of other parameters in your dataset. So what is appropriate value? Again, it depends on a lot of different things, and you have to think specifically for each case. It differs from one case to another, from one dataset to another dataset, from one data mining task to another data mining task. And as you gain more experience in data analysis and data mining, it'll be easier for you to figure out what would be the appropriate value for missing data. Another strategy is to exclude records containing missing values from analysis. Sometimes that you have records that they have a lot of missing values. Let's say that you had a careless respondent. You were gathering data through surveys, and there were some people who just did not feel like answering a lot of your questions, so they generated a lot of missing value for their record. If you have those people, if you have those records, you can go ahead and safely remove those records from analysis. Again, if you have any control over data collection, you can reduce these things. You can reduce the number of missing values per record by mandating your users to answer each and every question, to not letting them skip any question, so you're not letting them to generate any missing value. Again, depending on how you are conducting the survey, the environment, the authority you have, you may not be able to actually force your respondents to answer all of the questions. But if you can do that, it'll save you a lot of headache further down the road. And finally, the last strategy in dealing with missing data is dropping the variable with lots of missing values from the analysis. Going back to the example of where missing data or missing value might be expected, the answer to the question, do you use other social networks than the ones that we already asked about? So you expect to see a lot of missing value, and when the survey is done, you can see that, okay, yeah, there are a lot of people who did not use any other social networks than the ones that you asked about, so they left it blank and it generated a lot of missing values. You can just go ahead and remove that variable from your analysis, take it out. So if you have one variable with a lot of missing value, again, it's one of the easiest ways, or one of the best strategies is to go ahead and remove that variable from your analysis, because if you include it in your analysis, it is going to introduce more error into your analysis and you will have less accurate results. Next, within the data preparation phase is to create a model set. This is specifically important if you are trying to use a predictive model on your data, or you are trying to prepare your data for a predictive task. It is of less importance and almost hazardous to descriptive data mining tasks to create a model set. I already talked about this, creating a model set. So what is a model set? Model set is a sample set, is a balanced sample that contains equal number of each outcome. Let's say that you are looking at a categorical target variable. For example, you want to predict how customers are going to spend, how a new customer is going to spend money on your products and services. You typically can categorize your current customers into high spenders, medium spenders, and low spenders. In a normal distribution of data, you will get less of high spenders and less of low spenders and a lot of medium spenders. So if you go ahead and download and use that your old customer data or your current customer data as it is, you will end up with only few high spenders and only few low spenders. This data set is unbalanced. For predictive tasks, you typically want to have a balanced data set where you will get equal numbers of high spenders, equal numbers of medium spenders, and equal numbers of low spenders. So why is this important? Let me give you an example. Imagine a coin toss. Can you predict the coin toss, the result of a coin toss? Like, certainly, can you tell me if I toss a coin, will it be heads or tails? So some of you would say, okay, 50% chance that you know it's going to be either heads or tails. But can you tell me with certainty which one is going to be? Most probably no. How about that? How about this example? I have a glass cup in my hand and just it falls off of my hand into the floor. What will happen to it? Let's say that it falls off into a slabbed floor, a cement floor. Again, you probably would say it'll just break and it'll shatter. The glass will be shattered all over the floor. So why is that you can predict what will happen to the glass cup with more certainty than what will be the result of the coin toss? The reason is based on your experience. You have seen a lot of glass cups falling down and shattering. So when a glass cup starts falling, the first thing you say, oh, it's going to shatter. And if it doesn't, then it's going to be an exception for you. Why? Because in many occasions you have seen glass cups or glass anything falling down the floor and just being shattered all over the place. But you probably have seen thousands or maybe hundreds of examples of coin toss. But in none of those cases you were able to completely predict what would be the outcome. You can do you do this predictive task based on your past experience, based on what you've learned in the past. It's the same principle for computers. Computers can predict the future based on the past, based on learning from the past. So if you are not able to provide enough examples for them to learn from the past, they will do a poor job of predicting the future. So you need to make sure that if you are going for a predictive task, you are going to have a balanced sample. It means that you will have equal or a number of all outcomes. And it is important if your target variable is categorical. It's much less important if your target variable is continuous, it's not categorical, so you are going to use some sort of regression model on it. You should also note that not always you are able to create a model set for predictive tasks. Sometimes your data is very limited. You don't have access to the source of data. You are just given a sample, a limited sample, and you have to work with it. And if you want to create a model set or a sample set based on that sample, you are going to lose a lot of data points. So not always it's possible to create a model set. You should remember that if you are going to do a predictive data mining task and you are not able to create a model set or a balanced sample set, you have to put this down in your final report. You have to mention this as the weakness of your modeling, as a limit, as a restriction on your modeling, and something that can potentially affect your results. And finally, let's talk about some lingua franca, or some common language that is used in data analytics. You will hear me using different words for the same concept. It is very important for you to learn these, not because I use different words referring to the same concept, because different analytical applications or data analysis applications, different authors, different teachers use different words referring to the same concept. Starting with attributes. Attributes are characteristics. You may hear characteristics instead of attributes. You may hear features, influence factor, indicator, variable, signal, column. So when you look at data table, a tabular format, usually you have the column names on top, and then you have your records on the rows. So columns, they contain attributes or variables, and rows contains records. Let's imagine an employee table. You have the first name, last name, employee ID, a salary, date of hire, and whatnot arranged in columns. And each individual employee, such as myself, Reza Vazi, they are in one row that you can see their first name, last name, date of hire, salary, and whatnot. So the column names are called attributes, characteristics, features, influence factors, or simply factor, indicator, variable, signal. They're also called independent variables in most cases. Independent variables are the variables that affect or impact your dependent variable or your target variable. The next one is called label. Label is a specific name that RapidMiner software uses for your target variable. Label variable or target variable is the variable that you want to predict in a predictive analysis. It's the attribute that you want to predict. It's also called target variable or target attribute or target factor. So you see, I can use any other names that I use for attributes that are common for attributes. It is also called dependent variable, especially in regression analysis. A label or a target variable is called dependent variable, and when you are reading a statistical text, or when you are reading different textbooks, you may just see dependent variable instead of a target variable or instead of a label variable. The next one is called concept. Concept is the entity, is the table. Again, employee table. Sometimes it's called example set, especially in RapidMiner. Example set refers to a data table, refers to an entity. And examples are like customers, employee, product, and whatnot. And the last one is called example. Again, example is something that RapidMiner uses a lot. The other names for example are called instance, row, record. And in the example of employee Frank Miller is a row, is a record, is an instance, is an example of employee. Reza Vaezi is one of them. Or mountain bike is just like a customer. So again, attributes refer to the column names, and it can be referred using different names such as feature, variable, indicator, factor, sometimes independent variable. Label is your target variable. It can also be called dependent variable. It's the variable or it's the factor or it's the attribute that you want to predict. Concept is your data table, is your entity. It is also called example set in some applications including RapidMiner. Example is the record, is the instance, is that one row within your table. So it is very important for you to know this language, and you know when different words are used in place of each other that are referring to the same thing and to the same reality, I would say, to the same object.